MCV4U1, Chapter 1, Session 9. In this session, we are going to work on Section 1.4 from the textbook, the limit of a function. This notation is used for showing limit of f of x as x approaches a equals L. And it means the value of f of x can be made arbitrarily close to L by choosing x sufficiently close to a but not equal to a. Limit of f of x as x approaches a exists if and only if the limiting value from the left equals to limiting value from the right. The book starts with an investigation determining the limit of y equals x2 minus 1 as x approaches 2. There's a table of values given and asked to complete the table. Just plug in the numbers into the function and complete the table. By doing this, you'll see when x is 3, y is 8, and when x is 1, y is 0. And when you complete the table, you'll see from both sides, when x is getting close to 2, y is getting close to 3. And if you sketch the graph of the given function, it is a parabola. The vertex of the parabola is 0 and -1. It's passing through 2 and 3. And if x is getting close to 2 from either side, y is getting close to 3. Determine the limit of x2 minus 1 over x minus 1 by using a table of values. The first step is setting up a table. We select a sequence of the numbers for x approaches 1 from the left side. That means x is getting close to 1 and it is smaller than 1. And x approaches 1 from the right side. X is bigger than 1 in this case. So from the left side, we start from 0, 0.5, 0.9, 0.99, and 0.999 from the left side. From the right side, we start with 2, 1.5, 1.1, 1.01, 1.001. As you see, x approaches 1 from either side, and we are looking for y values. What we do is calculating y values when y is x2 minus 1 over x minus 1 and complete the table. Looking at the pattern, we'll see from the right side when x approaches 1, x2 minus 1 over x minus 1 approaches 2. From the left side, when x approaches 1, f of x also approaches 2. This pattern suggests that the limit of x2 minus 1 over x minus 1 as x approaches 1 is 2. There are ways to confirm it. One way in the book is using a graphing calculator, sketching the graph of x2 minus 1 over x minus 1 using a graphing calculator. x2 minus 1 over x minus 1 and x plus 1 are the same when x is not 1. Therefore, the graph of y equals x2 minus 1 over x minus 1 is a straight line and it is undefined at x equals 1. By looking at the graph, we'll see as x approaches 1, f of x approaches 2. Next example, example 3. A piecewise function is given. Sketch the graph of the function f of x equals x minus 1 if x is smaller than 1, 1 if x equals 1, 2 plus square root of x minus 1 when x is greater than 1. And determine limit of f of x as x approaches 1. When x is smaller than 1, we have a straight line, x minus 1. Y equals x minus 1. But only the part that x is smaller than 1. That means we don't have this part when x is more than 1, and we also don't have x equals 1. This is shown by a hollow point. When x is 1, y is 1, it's a point on the graph. And for x greater than 1, we have 2 plus square root of x minus 1. When x approaches 1 from the left side, f of x approaches 0. And when x approaches 1 from the right side, the limit of f of x is 2. Since the right side and left side limit are not the same, limit of f of x as x approaches 1 does not exist. Let's recap. Limits and their existence. We say the number L is the limit of the function y equals f of x as x approaches the value a, and write it using this notation. If the limit of f of x as x approaches a from left side equals limit of f of x as x approaches a from the right side equals L. Otherwise, the limit does not exist. So if the limit exists, the right side and left side limit are also the same. Next session, we are going to work on questions on page 37, 38. We do question 5, 6, 10, B, D, and F. And question number 12. Thanks for watching.